In our previous video, we discussed the central limit theorem that told us under our conditions that we have a random sample, we either know the population is normal or have a sample of at least 30, we can use a normal distribution to approximate the sample mean. Our goal in this video is to apply this to our first example. So in our first example here, we are looking at cholesterol levels of adults in the United States. It says that they are normally distributed with a mean of 175 and a standard deviation of 45. So just by reading that, I know three important things. One, I know that the mean is 175 and that my standard deviation is 45. Now notice I use the population symbols of mu and sigma here because it hasn't said anything about taking a sample yet. So this is what we're assuming is true for all adults. The other piece of information that was given to me that's important is that we know it's normally distributed. What that means, I now know that the picture of my individuals is going to have this bell-shaped curve. So that's going to be important for me as we continue the problem. The first question asks us to find the probability that an adult has a cholesterol level greater than 200. So whenever we've been asked to calculate a probability, we generally start with a picture. So our mean is 175, and we draw our little scale and increments of our standard deviation. Here, the standard deviation is just the 45 that we're working with. So I'm going to subtract 45 every time we go to the left, giving me 130, 85, and 40. And then adding it each time that we go to the right. So we're going to get to 220, 265, and 310. Now it asks me to find the probability that it's greater than 200. So 200 falls roughly about here. So it's between 0 and 1 standard deviation above the mean, right? Because this is 1 standard deviation above. And then since it says greater than 200, that's going to tell me to shade to the right. Now it's like we're back in the normals notes. So I'm going to be using my Z formula, but since we discussed a different Z formula last time, let's make sure we feel good as to why we're going to use the one we're going to do. Are we interested in the mean of a group or a single individual? Well, it says here in the problem that we're looking at an adult. So we're just looking at a single individual, which then means I'm going to use that individual formula, which is just the y minus mu over sigma. So in this problem, the y is just our 200 that showed up there. The mean is 175, and our standard deviation is 45, giving me a z-score of positive 0.56. Again, because we're above the mean by less than 1 standard deviation, so we're between 0 and 1 for our z-score. Next, we're going to take that value and look that up in our z-table. Hopefully you feel good about reading the table at this point. And we would find a value of 0.7123. But recall that our table always reads what's to the left of that number, and our picture here is shaded to the right. So to find my probability, I'm actually going to have to use that 1 minus rule, giving us a probability of 0.2877. So now if we were to interpret that, we would say the probability that an adult has a cholesterol level greater than 200 is our 0.2877, or would be 28.77%. So that's old stuff, really. For our next question, it says, if we were to take a random sample of 25 U.S. adults, we want to find the sampling distribution of the statistic of interest. So when we're asked to find a sampling distribution, we're going to check the appropriate conditions. These conditions are different than the ones we've looked at in many previous modules because we have a quantitative variable now instead. So we're going to be checking these conditions to hopefully say that the sample mean is approximately normal. So we need to check first if we're taking a random sample. It does not say much in the problem. It just says if we take a random sample of 25 U.S. adults. So at least from what we know, it's not going to be biased. For the second condition, do we either know it's normal or have a sample of at least 30? Well, our sample size is only 25, so that's not at least 30. So do I know that it's distributed normally? Well, I do actually know that. That's what it said up here in the problem, that it was normally distributed. So this part is actually going to be true for us simply because it was stated in the problem. Now, it may not always be stated. Sometimes I might be looking at that histogram instead to see if it looks unimodal and symmetric. And that would also be justification to say that it is normal. So that's it for my conditions. So since the conditions are met, I will be able to say that the sample mean will be approximately distributed normally. And then again, we need to come up with the mean and the standard deviation. So the mean of y bar is just whatever that population mean is. So that's just going to be our 175. Our standard deviation of a y bar is just the standard deviation over the square root of the sample size. So our standard deviation is 45, and our sample size is 25, which ends up being 45 over 5, which just turns out to be 9. So that is what our sampling distribution looks like. Finally, we're asked to find the probability that the mean cholesterol level of 25 randomly selected adults is greater than 200. Again, we're asked to find a probability, so I generally start with a picture. Alright, so is this picture going to be exactly the same as we had up here? So how is this problem different than the one that was stated up here? Here we're looking for an adult having a cholesterol level greater than 200. Now instead we have the mean cholesterol level of 25 randomly selected adults. So what that means is I need to actually be using my values from up here. This is the mean I need to be working with, and this is the standard deviation I need to be working with. So my mean is still going to be 175. But now when I go out in my increments here, the size of each of these steps is only going to be 9. That's sigma over the square root of n that we found above. So subtracting off my 9 each time will give me those values, and then adding on 9 each time will give me those values. So the idea might seem similar, but our scale is different than the one we had above, since now we're working with the mean cholesterol level of 25 adults. But our goal is still trying to find greater than 200. Now 200 is over here, and we're still shaded right due to the greater than part. But what I can already see from my scale is 200 seems to be further away from the mean because the size of my step has changed. So now we are between 2 and 3 standard deviations above the mean. What this also means for me is when I'm going to calculate my z-score, this is going to be the z-score formula I want to use because we're looking at the mean cholesterol level of 25 adults. Now, applying that to our problem, how does that look? So again, I'm just going to first write the formula. You do not have to write the formula each time for me. So this is our formula now. This time the mean that shows up in the problem is 200. The overall mean for all U.S. adults is 175. And the standard deviation for 25 adults is this value that I already found up here, right? Sigma over the square root of n. That's what I'm being asked to find. So it's just going to be this 9. I've already done the math. I don't need to do it again. And now when I get my z-score, it's 2.78. Again, because we're between 2 and 3 standard deviations above the mean. We're going to go to the table in the same way that we have before. This time we'll find 0.9973. Again, that tells me what's to the left of that number, but I want what's to the right of that number. So we use our 1 minus rule as before, giving me a probability of 0.0027. So as you can see, comparing our answer here in this part to the one we had above, we have a very different answer for our probability. So writing out this interpretation may actually be useful for us to really understand the difference in what we just found. So now I can say, well, assuming the mean really is 175 as they told me, the probability that the mean cholesterol level of 25 adults is greater than our 200 is our 0.0027, or which will now be 0.27%. So less than a 1% chance of that happening. Now, things to think about. Does it make sense why this probability was so much smaller than above? The probability of finding a single person who has a cholesterol level greater than 200 is much easier to find than having an average of 25 people being at least 200. The same would hold true if we think about trying to find the probability that a student scored at least a 90% on the test versus the probability that the mean score of 25 students being at least a 90 is probably pretty unlikely to happen. So we see a very big difference in the answer that we get. Then that also means that our goal is different. We're not looking at individuals, we're now just focusing on the mean. So that finishes our first example. In the next video, we will do another example.